Hi, my name is Angelo Carvalho, Principal Solutions Architect at AWS, and I'm joined with Kunal Agarwal from Unravel Data. It's great to be here with the Data Ops community, and I'm very excited to show you how Amazon EMR can help you to accelerate data processing and data ops. Data is the core behind every business and every decision. In today's world, these are the new realities and also challenges that customers are facing. First would be the explosion of data, where connected devices, apps, and systems generate more data than ever before. Also, we have explosion of personas. We have more and more connected customers, employees who want to extract insights from data, and also devices. And now we have a demand for faster decision making that takes into account all the available information in near real time. So customers, they want to make decisions as the data arrives. This comes at a time when more and more businesses are realizing the value inherent in their data. Data volumes are increasing at a rate never seen before, exploding from terabytes to petabytes and sometimes even exabytes of data. Traditional on-premises data analytics approaches can't handle these data volumes because they simply don't scale well enough and they are too expensive. So we hear from companies all the time that they're looking to extract more value from their data, but they struggle to capture, to store, and analyze all the data generated by today's modern and digital businesses. Data is growing exponentially, so it's coming from new sources, it's increasingly diverse, and needs to be securely accessed and analyzed by any number of applications and people. So many customers are using open source frameworks such as Apache Spark and Hadoop as foundational elements for data analytics. This has benefits, but has challenges too. So customers can take advantage of those open source frameworks such as Apache Spark and Hadoop to help them to capture value from the data. But self-managing these open source frameworks, whether on-premises or in the cloud, is costly and is complex. It requires provisioning, operating, scaling, managing new versions or even multiple versions in the same environment. So customers who self-manage have to worry about operational efficiency issues, such as hardware and software installation, configuration, patching, and even backups, performance and availability issues, and also security and compliance issues as well, such as network isolation, encryption, compliance programs. All this work distracts the customers from the real mission, so they want to spend time innovating and building new applications that can create real business value, not managing the infrastructure. AWS can help with both managing the open source analytics services and also migrating from on-premises architectures. We do this as part of our holistic approach to data analytics, which we call the Lakehouse Architecture. A Lakehouse Architecture acknowledges the idea that taking a one-size-fits-all approach to analytics eventually leads to compromises. It is not simply about integrating a data lake with a data warehouse, but rather about integrating a data lake, a data warehouse, and also purpose-built stores and enabling unified governance and also easy data movement. The AWS Lakehouse Architecture supports the following characteristics, as you can see in the diagram. First, building a scalable data lake rapidly with S3. So in fact, customers have been building data lakes on Amazon S3 longer than any other cloud providers. And today, more data lakes run on AWS than anywhere else. This architecture allows customers to use a broad and deep collection of purpose-built data services that provide the performance required for use cases like interactive dashboards and log analytics, and ensure that they're using the right tool for the job to get the high performance and scale, and also the lowest possible cost. Customers can also move data seamlessly between the data lake and the purpose-built data services. Customers are using AWS Glue, our serverless data integration service, for this task. The Lakehouse Architecture ensures also compliance via a unified way to secure, monitor, and manage access to the data. So customers are using AWS Lake Formation to manage the security and the governance of all their data. In all these cases, we've invested heavily in offering the best price performance out there, so customers can scale systems at low cost without compromising on performance. Now let's talk specifically about Amazon EMR, which can simplify the managing of open source frameworks such as Hadoop and Spark. Amazon EMR is the industry-leading cloud big data platform for processing vast amounts of data. It uses open source tools such as Apache Spark, Hive, HBase, Flink, Rudy, and Presto. EMR supports a broad range of open source frameworks. It has 21 open source projects that are tested and integrated into a single solution designed to work together. Each project is updated in EMR within 30 days of a version release, ensuring that you always have the latest and the greatest from the community without having to spend time to test and to certify all those new components. Regarding performance and cost, EMR optimized runtimes can deliver better performance than open source distributions. For example, Spark workloads on EMR, they can run up to 2.5 times faster compared to open source Spark. Also, EMR pricing is simple and predictable. You pay basically a per instance rate for every second used with a 1 minute minimum charge. And because EMR has native support for spot and reserved instances, you can also save up to 80% on the cost of the underlying instance. As described in the Lakehouse architecture, EMR uses S3 storage, so it leverages Amazon S3 data lake directly. This allows users to scale compute and storage independent of each other, while providing 11 nines of reliability at a very low cost. EMR launches clusters in minutes, so it's very easy to get started. You don't need to worry about hardware purchase, node provisioning, infrastructure setup, Hadoop configuration, and even cluster tuning. EMR will take care of all those tasks so you can focus on analysis. And now let's talk about a few of these newer deployment performance and scaling capabilities that Amazon EMR now provides. Talking about deployment options. So basically you have three different options, right? So the first would be deploying on EC2. EC2 would give the broadest range of compute instances in the cloud to allow you to optimize price performance, including the choice of use AWS Graviton 2 processors. So Graviton 2 basically deliver great performance for many EMR workloads as a lower cost. Customers also have a second option, would be deploying Spark workloads on EMR with other container applications using EKS, or our Elastic Kubernetes service. This has the benefits of increasing utilization of compute resources, simplifying infrastructure management, and taking advantage of fast startup times in EKS. This includes the option to go serverless, if you want to do so, by using Fargate. And finally, if you want the benefit of managed services in EMR, but need to keep the equipment in your on-premises environment, AWS Outposts is also an option to run EMR. Let's talk about how the combination of the deployment options and EMR runtimes can deliver best-in-class price performance, better than open source and better than alternatives. Today, EMR is the fastest place to run Spark workloads. So Amazon EMR runtime for Apache Spark is a performance-optimized runtime environment for Apache Spark. To evaluate this Spark performance, we used TPCDS benchmark queries at a 3 terabyte scale. The query performance was up to 1.7 times faster for Spark 3 and 2.4 times faster for Spark 2, while running at 40% of the cost. We did a similar test using TPCDS at a 1 terabyte scale factor using EMR runtime for Presto, and we were up to 2.6 times faster. Amazon EMR also supports EC2 M6G instances in order to deliver the best price performance for big data workloads. Those M6G instances are powered by AWS Graviton 2 processors that are basically custom designed by AWS using the ARM architecture. The combined benefit of EMR runtime for Apache Spark and the Graviton 2 processors offers up to 76% lower total cost and 3.6 times improved performance compared to running open source Spark on equivalent previous generation instances without this runtime. EMR optimizations, it's important to say that they are fully compatible with the open source, so your workloads will run faster without any changes on your applications. So using these runtimes and Graviton 2 instances, it's a super easy way to speed things up and lower costs. In addition to very strong price performance, EMR also makes it very easy to react to workload changes and scale as needed. So there's a feature called EMR Managed Scaling that automatically resizes your EMR clusters for best resource utilization without the need to alter or to configure complicated scaling policies. With Managed Scaling, you just specify the minimum and the maximum compute limits for your cluster, and EMR will automatically resize your clusters based on continuous sampling of some key metrics associated with the workloads that you are running on the clusters. Managed scaling is useful in scenarios where the load on your clusters is unpredictable or the amount of data processed by the cluster can change over time. With this feature, you can save something between 20 and 60% costs, depending on your workload pattern. Ultimately, also customers, they have data engineering and data science work to do, right? So those two different personas, they can work together using EMR, and we have investing to simplify development on top of it. So we have a new feature in preview called EMR Studio. It provides a single pane of glass for data engineers and scientists. So the users, basically, they can log directly to the notebooks using their corporate identities. They can share notebooks using GitHub and other repositories. They can run pipelines with notebooks using Apache Airflow. And they can simply debug their applications using Spark UI and Yarn timeline services. Now that we've walked through EMR and some key features, let's talk about the other related services. As part of the Lakehouse architecture, we provide managed analytics services based on open source software to eliminate the need for customers to manage these on their own servers. AWS offers the broadest set of analytics services for customers to lift and shift their analytics workloads on the cloud. And customers are doing this at record levels across many different areas. So we already talked about EMR, so let's explore a few other options. If you want to do operational analytics, customers can move from their on-premises Elasticsearch, Logstash, and Kibana to Amazon Elasticsearch service for cost savings and also for having a managed service. If you want to do real-time analytics, you can also move from Apache Kafka deployments to Amazon managed streaming for Apache Kafka, and also you can use Amazon Kinesis data analytics for Apache Flink. In all those cases, by moving to AWS Analytics, you will basically avoid the heavy lifting of self-managing the software and potentially harder to run your big data analytics workloads. And now let's talk about how we help customers who want to take the advantage of EMR. We've worked with many customers to migrate from on-premises and other solutions to EMR. So a good starting point is the EMR migration guide, which you can download at the link shown on the slide. In addition, we offer the free Amazon EMR migration workshop, which is a virtual or on-site workshop, depending on the pandemic situation, that can jumpstart your Apache Hadoop Spark migration to Amazon EMR. And I will now turn it over to Kunal, who will present Unravel Data. Thank you very much.
Thank you, Angelo. Well, as you can see, AWS EMR has a lot of feature-rich capabilities for any data team member to actually spin up a quick data platform and get working on it very, very quickly. What we're going to focus on now is how to go and manage and optimize those data applications, those data pipelines, and the resources that these applications are running on in a very simple and automated manner. We are excited to partner with AWS on this. And Unravel's mission is to radically simplify data ops. And we provide an AI-powered observability and optimization platform that helps data teams achieve fast applications and efficient applications in a very easy manner. You see, data teams and all the data engineers and the operations folks, they really just want to create value out of the business applications that they're creating. But too often, they get bogged down with all of these different issues that keep plaguing them all the time. They may have their data pipelines that are missing SLAs, or their data applications are just slow today, or they're just breaking, or they're failing. And on the other hand, you may have these applications overshooting their budgets by 2 or 3 times. And when the data teams sit down to try to resolve these issues, it usually takes them a long time to go and understand what it's happening, why is it happening, and how they can fix these issues. And the reason for that is either the data is not available, because a lot of times if you're running a transient environment, all those logs and metrics are no longer available, or that data is just too hard to decipher because there's just logs and metrics, and stitching all of those things up may take a long time, and may take a long time to even go and comprehend what's really happening over there as well. So we've tried to simplify that here at Unravel. So first of all, Unravel is designed for everybody on the data team, starting with the developers, the data developers, which come in the form of data engineers, or you may have data scientists or data analysts who are really creating these data applications and pipelines on these systems. And on the other side, we also help the operations team, which could be the administration team or the SRE team, who is usually your first line of defense when things go wrong. And Unravel is also designed for the managers, the data product owners, or the architects who've put this entire piece together to solve these business needs as well. And Unravel can help out with a couple of things out here. Number one is application and pipeline optimization. Understanding how your applications and pipelines are doing end-to-end. You may have several different stages doing several different things and seeing all of them together. And then how these applications are actually behaving and executing and performing. In addition, all of the different factors that could affect the performance of an application are all put together in one place, whether that's the data layout, whether that's the resources, the code itself, the configuration settings. And Unravel not only presents all of this data, it then uses algorithms to go and detect problems, failures, inefficiencies, to go and crack the code on what's going on, and then be able to resolve those problems as well. And the other side is Unravel looks at your cluster as a whole and helps you understand where can you improve efficiency and where can you save some cost by running these applications in a much more efficient manner. It's constantly hunting for inefficiencies, such as, is there a better instance type that you could be running these workloads on? Or are there applications that are wasting resources that don't need so much capacity, for example? And it does that in a very automated fashion as well. Now, Unravel deploys seamlessly. You can deploy it either within your own VPC, or you can use the Unravel SaaS service, and it integrates with your entire data platform as well. All the different orchestration tools, all the different processing engines that you may have, so that you can see everything together in one place. Now, there's a lot of different types of benefits that our customers get, but on a high level, there are a few common patterns that we see. Unravel helps you dramatically improve the performance of your applications. We've seen 2x to 5x improvement in a lot of different cases. But more importantly, it helps you run those applications and pipelines reliably, making sure that they run on time every time. We've also seen a drastic reduction in troubleshooting time. Things that take days, sometimes weeks to go and resolve, Unravel can help you resolve those issues with the click of a button. And we've also seen all of these platforms usually have some inefficiencies in the way the applications are running on top of them as well. And Unravel has helped save 30 to 50% in the running costs of these applications and data pipelines as well. And last but not the least, we understand that your modern data stack is made up of several different components, and Unravel gathers data from each of these different components to stitch them all together and present it in one place. So your entire data team has a single source of truth and one place to come in and collaborate off of. And I think that's just very, very important. And the way Unravel does this is it gathers data from the full stack. So it's got information about applications, everything from the code, the execution plan, all the metrics. It's got information about resources, what's utilized, what's allocated, your container level metrics and logs, all the information about configurations and settings, information about the data sets themselves, and then information about all the users, the user groups, the businesses, the projects that you may have running on this particular cluster or clusters. And it connects with all of these data sources seamlessly and deploys a lightweight sensor to be able to send all this information to the Unravel service. And once all this information comes in, Unravel first creates a data model where it connects and correlates all these different pieces of data together, and then applies algorithms on top of it to be able to uncover failures, slowdowns, root causes of problems, and then helps you resolve them in an automatic fashion. This shows a lot of different tuning suggestions that I'm going to show you quickly in a demo. It can also be proactively alerting you about these problems and taking action on your behalf even. So not just alerting, but a remediation for it. And then very rich analytics in the form of dashboards that help you understand what's going on in the cluster, who's utilizing it, and all the other problems that plague your environment every day. So let's jump into a quick demo here today. We'll be running through two demo scenarios. One is going to be around applications and pipeline optimization, and the other one is going to be focused on the resource optimization itself. So let's jump into the application or the pipeline example first. So in this case, I've got Unravel connected to several EMR clusters. I may be running permanent clusters or transient clusters. And you can see right here that Unravel has started to produce alerts about some slow running applications on your environment. Clicking on which, I've come inside a data application or a pipeline page. In this case, it's a very simple Spark application that I'm running. Your real world application may have many stages. It may be connected through Kafka or a data ingestion platform, bringing data into Spark, doing some manipulation on top of it, shifting it to an MPP platform, and then visualizing it. You can see that entire flow end to end over here in all of these different stages. In this case, it's a very simple 2-stage app. But I can see that the application took about 12.5 minutes to run. And I have all the information that can affect the performance of this app in one place, from the code to understanding how resources are being used by this particular application, all of its different stages. I can even go and drill down into all of those different components to further get more fine-grained information about how this is actually executing on these machines. So really all the information at your fingertips. As you can see, you don't have to hop around multiple different tools to go and get all of these things in one place. But Unravel takes it above and beyond from there. And you can see right on top, it says, Unravel's analyzed this application, and it's got 4 recommendations that it can use to improve the application efficiency itself. So clicking on this, Unravel opens up all of the different recommendations, very pinpointed recommendations to go and improve the speed or the utilization of this app. And in this case, it's telling you that, hey, we figured out some configuration settings that you should be running this application with. And if you apply them, then there could be a dramatic speed up in your application. Or there are ways in which this application could consume fewer resources. So you could cut down your cost of running this application because there's a more efficient way to run this as well. Now, this is just one example. There are several such examples. If your application was failing, then Unravel would give you recommendations for how you can go and remove those errors and failures from your application, run them successfully. Or you could be doing this across the whole pipeline. So it could tell you which stages are the bottleneck stages and where you need to actually focus on to make sure that your applications are adhering to those SLAs. For the next example, let's jump into the resource and cost optimization. So what I'm looking at here is all of my different EMR clusters aggregated in one place. And then I can view analytics in any shape or form that I need. In this case, I've decided to see this information either by the different cluster types that I have or by the different tags that I may have provided when I was spinning up this EMR cluster. So I actually defined a purpose tag in my EMR environment. So as you can see, is gathering up information from all of these different clusters and aggregating it out here. So on a bird's eye view, I can start to see that my default cluster is the one that's eating up most amount of cost, although it's got about 37% of usage, whereas my other environments are at about 12 to 16% or so. And then you can see this insights icon next to each and every cluster, which then helps me understand, hey, what are the different ways in which I can improve the efficiency of all of these different clusters that I'm running them. So simple click here gets me to the insights page, which is then showing me what are all the different recommendations that I can do at the cluster level itself to further save some cost. In this case, if I zoom in, it shows me that I can save some money by actually using a different type of instance. As you can see, AWS has multiple instance types, and selecting one, you really need to know the requirements of that app or that workload that you're running, and Unravel does that for you. So in this case, it's saying, hey, I don't need to run M42 extra larges. The same app can actually run efficiently by using M6G extra large, where I would save $14 to actually run this workload on. Now, obviously, in the real world use case, you could see potential savings of thousands of dollars like this. And there are other types of recommendations that Unravel can help you out with as well, which could be in the form of using spot instances, for example. Now, spot instances are great when you don't have very long workloads or you don't have workloads that are bound with SLAs. If you have those kind of workloads running in your environment, then Unravel will be able to spot those for you as well and help you understand where can you run those workloads with assurance so they actually run well, but they run in an efficient manner as well. Last but not the least, you can set up guardrails with Unravel so that you can proactively prohibit a behavior from happening on your environment. So anything from a long-running application to users or pipelines taking too many resources, you can set those up in Unravel, and then you can get everything from alerts to automatic action that, hey, if this condition is met, go and notify the admin, or if this condition is met, stop that application from running because we don't want to spend that much money on that particular run of that application as well. So you can see this way you can be proactive instead of being reactive, where you are fixing those problems as they're cropping up on the cluster itself. So that's all I have today for this quick demo. Again, if you wish to learn more about how Unravel can work for your EMR clusters, do check out unraveldata.com. We do have a free trial, a free SaaS trial that's super easy to get up and running in a couple of clicks. You can also access that through unraveldata.com. And if you are on the AWS Marketplace, you can also subscribe for Unravel through there as well. And that's how AWS and Unravel are simplifying data ops. Thank you very much.